Hey everyone, I'm McCabe Levingood, and this is my Physics Lab 4 on bar magnets. The main goals of this lab are to measure the distance dependence of the magnetic field due to a small bar magnet, and to compare measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields. Here are some important concepts we'll need to know for the lab. First, we have the Biot-Savart law, and then some equations that have to do with the magnetic dipole, the magnetic loop, or the magnetic field of a loop, and then also the magnetic dipole moment. Now I'm going to walk everyone through the experiment that we did. First, just to specify, the system was the observation location, which in this case was the magnetometer, and then the surroundings were the bar magnet. And first we measured the on-axis magnetic field and then the off-axis magnetic field. Here are my results from the experiment. As you can see, we measured the magnetic field at different distances, and then we averaged those values to get the average distance and then the average magnetic field measured at that location. From this experimental data, we found that when the magnetometer was far away from the magnet, it measures a near zero magnetic field in the x direction, and as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Now for the computational portion of this lab, the first thing we're going to do is calculate the magnitude of the magnetic dipole moment, and these measurements are just from what we did in the experiment. And then we create a function for the magnetic field, and this is basically just corresponding with the equations that we went over previously. Then we're scaling the arrow and inputting the distance from the different observation locations, and then basically the rest of this code is establishing an axis and position for these different observation locations and creating arrows to represent the magnetic field perpendicular to these points. And that is pretty much about it for the code. Here are the computational results. As you can see, we have the different arrows, and then we have the values for the b-axis 1 and b-axis 2, and then the perpendicular values and the distance. As you can see, some of the values differ between the computational versus the experimental results, and I believe a lot of this has to do with the external magnetic fields that were surrounding our experiment, that came from our other phones, laptops, other magnets in the room. There are a lot of other magnetic fields at play that we weren't considering in our math and in our computation. So I think that's one of the main reasons why these values differ. Now, to wrap up this lab, what if we hadn't oriented the experiment to compensate for magnetic north and then had instead laid out the meter stick at some intermediate angle with respect to Earth's magnetic field, and how would my results have changed? The x components would be different because the magnetic north would contribute to the magnetic field measurements, and the y components would also be different due to not accounting for the magnetic north. And if we were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? And the magnitude of the magnetic field would increase due to the combined magnetic fields from the two magnets. So basically, the magnetic field would be multiplied by 2. And that's it. Thank you.